civil and industrial engineering, construction often entails digging deep into permeable ground below the water table. Excavation in loose ground, however, cannot be carried out below the static level of the water table, owing to the continuous reflux of water mixed with soil. The level of the water table must be lowered below the bottom of the excavation. Correct drainage ensures stabilization of the slopes of the excavation and surrounding soil, elimination of the risk of the bottom of the excavation rupturing, reduction in the hydrostatic pressure on any excavation reinforcements, like piles or diaphragms, easy excavation and transport of excavated materials. The alternative use of waterproof diaphragms, piles and self-driven caissons is not only more expensive, but is not always feasible and effective if these structures are not installed in an impermeable layer of adequate consistency below the water-bearing soil to be excavated. This prevents both piping and seepage through the bottom of the excavation due to strong uplift pressures. The determining factor, and the most difficult one to establish, which influences the choice of the type of drainage to use, is the soil profile of the ground with its permeability coefficient. The presence of surface water, streams or the sea near the excavation work does not necessarily affect the level and flow rate of the water table. Soil analyses must therefore be extended, not only to establish load-bearing capacity for the purposes of future loads, but also to assess correct dewatering procedures. The most modern systems of drainage commonly used are normal or direct suction, Welpoint systems, horizontal drainage, and wells. Direct suction can be performed with any type of self-priming or submerged pump, and consists in pumping the water from the excavation directly through the suction pipe and a grating at the bottom. It is used specifically for lowering and emptying operations of medium size and duration in fairly compact, silty, clayey soils with low permeability, or for stable gravelly soil with high permeability, in which case high delivery pumps must be used. The system inevitably causes wear on the pumps and pipes due to the presence of solid parts sucked in with the water. This can also affect stability of the slopes and surrounding earth. The Welpoint system is the most widespread and economic drainage system, especially for lowering the water table between 4 and 4.5 meters. Greater depths are also possible using special procedures. The system is characterized by the use of a pump, provided with vacuum pump and a perforating filtering tip, i.e. the Welpoint. Basically, the Welpoint system consists of a set of horizontal header pipes connected to one or more suction or backup pumps. Leading off from the horizontal header pipes at varying center distances are special flexible joints connected to the vertical riser pipes, driven into the ground at the required depth, with the well point fitted at the end for suction of the filtered water. The swirl pumps manufactured by Uniservice are designed for 24-hour non-stop use and use over long periods in particularly severe environmental and meteorological conditions. The vacuum pump fitted on the Uniservice swirl pumps not only guarantees rapid, safe, automatic priming, but also produces a high vacuum level in the ground, thus increasing the influx of water, which is driven towards the well points by the atmospheric pressure. As the pump well point circuit is in a vacuum, it must obviously be airtight. Even if air leaks from the joints and pipe fittings, however, operation is nevertheless ensured by the high air expulsion capacity of the vacuum pump. The plant suction pump must above all provide for a continuous expulsion of air due to the leaks in the system, or, in the case of soil with poor permeability, simultaneous absorption of air and water through the individual well points. The well point consists of an end with perforating tip and a set of metal or screened plastic filters. The Uniservice well point has been designed for sucking most water from the soil per unit of time, without removing solid particles. This result has been obtained by accurately balancing the pipe areas and the spaces between them. The external perforated pipe allows less water to pass through than the internal pipe. This difference creates a pressure drop between the two walls. The reduction in pressure on the filter and sand contained in the space between the external mesh and internal filter determines a low influx speed, which is kept constant throughout pumping. In this way, the water filters through a fluid sand bed with high filtering power. The flow rate of the Uniservice well point is approximately 160 litres per minute. In ground with particular granulometry, coarse sand or gravel, special filtering tips must be used, consisting of a steel pipe provided with holes with varying diameter and centre distance, capable of ensuring very high unit flow rates in the order of 250 litres per minute each. In this case, it is the soil itself that acts as a filter, settling around the tips according to the granulometries selected by suction of the water through the holes. The depth, centre distance of the well points and length of the riser pipes are determined by the type of ground, its permeability, and the lowering value required with respect to the undisturbed level of the water table. The plant can be positioned laterally to or along the perimeter of the excavation, according to the dimensions of the excavation and soil profile. When the water table has to be lowered by more than 4 to 5 meters, the multiple stage system is used. A Welpoint system is positioned axially or perimetrally to the area to be excavated, temporarily or permanently, depending on the depth of the excavation, permeability and type of ground. Once an initial drawdown has been obtained, the second system is positioned at the depth of the partially lowered water table. When the water table has reached the required depth, and once the second system is working, the upper one can be removed if suction via the lower one is sufficient. With this system, an installation with 2 or 3 stages operating simultaneously may be advisable. In the case of deeper excavations, which require more stages, it may be a good idea to use a mixed drainage system, consisting, for example, of deep wells operating simultaneously with the Welpoint systems. As regards driving in of the Welpoint systems, Uniservice uses different techniques according to the consistency of the ground. In loose, sandy ground, jetting equipment is used, with force suction water pump, which can develop high pressures. The jetting pump is connected to the riser pipe, with the well point at the end, by means of appropriate hydrants. The pressurized jet of water makes a hole in the ground, which allows the tip to penetrate to the required depth. In silty clayey soils, or in clayey soils in general, and sandy soils with gravel or fine gravel, or in any case more compact soils, appropriate hydraulic augers are used, consisting of a continuous propeller driven on top by a hydraulic motor, connected to the arm of an ordinary digger. The well point, connected to the jetting pump, is placed in the auger hole, and after the drilled hole has been thoroughly cleaned, connection to the header pipe is then carried out. Decimal pezzo. In ground with hard interbeddings, such as calcarenite or tufa, rotary percussion augers are used. Where there are uneven layers, impermeable interbeddings, or clayey lentils between the well points installed and the static level of the water table, this obviously obstructs the flow of water through the filters. In this case, pre-filters are used, boring by means of one of the methods described, but increasing the diameter of the hole. During installation of the well point in the hole obtained, while the jetting water comes out of the filter at low pressure, the entire height of the hole must be filled with sand of appropriate granulometry, sized according to the granulometry of the material in situ. This will maintain communication between all the layers crossed, considerably increasing the flow of the groundwater towards the well points. A new technique has recently been added to the traditional vertical well point system: horizontal drainage. Horizontal drainage consists in laying underground, using appropriate drain laying machines, special flexible corrugated PVC drainage hose of variable diameter, suitably drilled with holes and covered with a nylon or non-woven fabric gauze. The hose is connected to a suction pump on the surface to obtain temporary lowering of the water table. Diameter and length of the horizontal drain vary according to the type of ground, the permeability coefficient, and the type of pump used. The Uniservice B500 drain layer is a large caterpillar driven by a 335 HP 12-cylinder air-cooled engine. The vehicle features hydraulic adjustment of the distance between the tracks, which allows for reduction of the specific pressure of the machine on the ground to 0.4 kilograms per square centimetre, providing excellent performance on various types of ground. Maximum drain layout of the B500 is 200 meters per hour. The excavating device consists of a sturdy roller chain with special scoop buckets that dig the soil and redeposit it in the trench previously excavated. During work, it is most important that the excavation and laying equipment operate from a perfectly vertical position. In addition to ensuring correct installation of the PVC hose, use of the Uniservice B500 drain layers improves permeability of the ground at the level of the excavation, increasing the flow of water towards the drainage pipe. The advantages of the horizontal well point can be summarized as follows: less labor required than with the traditional well point, no equipment at ground level, which not only facilitates excavation and refilling operations, but also means that machines and vehicles can move freely on the site. The drainage pipe can be reused. Laying of the drain independently of the state of progress of the work. The pumps are connected according to site requirements. Reduction of the amounts of water to be pumped out for positioning of the drain immediately below the bottom of the excavation. Crushing and remixing of the soil beddings, increasing the flow of the water towards the drain. Possibility of operating without paths, even on less consistent ground, due to the width and adjustment of the distance between the tracks. The water table is lowered more quickly than with the traditional well point, under the same soil conditions. The maximum drain laying depth of 5 meters from the site plane could in some cases be a drawback. Finally, the well drainage system is suitable for temporary lowering of the water table when A. The permeability of the ground increases with depth, B. Subsequent excavation involves sandy ground, or in any case permeable ground with coarse granulometry, C. The layer of earth below the bottom is permeable and thick enough to allow for adequate immersion of the screened part of the wells. The wells are divided into large diameter wells, when the diameter exceeds 50 centimeters, and small diameter wells. The large diameter wells are used to drain surface excavations in water tables with creep. They are made using 1 meter overlying vibrated reinforced concrete rings drilled with holes, self-driven into the ground by means of excavation inside the elements. The small diameter drains are for draining deep excavations in artesian or semi-artesian water tables. They are made using rotating probes, which bore and destroy the core, and then lay a steel or screened PVC filter jacket over the whole thickness of the groundwater level. Electropumps of suitable diameter are positioned inside the wells, or the water is sucked out via flexible pipes connected to pumps on the surface. In some cases, the wells can be used in conjunction with the Welpoint systems. Wells are used when the bottom of the excavation coincides with a relatively impermeable layer above permeable soil under artesian pressure, to prevent heave or collapse of the soil, even though drainage has been carried out by means of the Welpoint systems. If the hydrostatic pressure in the permeable layer is higher than the pressure of the ground above, the bottom of the excavation will heave at the weakest points where the layer of less permeable ground is thinner. In these cases, the use of deep wells on their own, or together with the Welpoint system, eliminates all risks during excavation. The wells are normally spaced according to the lowering depth required, the permeability of the ground, and the immersion height available for the screened part of the well.